Thank you so much for the warm welcome. As Christoph already said, my name is Alexander Zeilmann, and I want to talk today about the past, the present, and the future of ECMAScript modules. So I already talked to a few people, and so I heard that not everyone is familiar with ECMAScript modules, but don't be afraid, I will talk about them later in this talk. But, well, first of all, what is a module system? What problem are we trying to solve? So nowadays, the applications we are writing are several thousand lines of code long, and it's probably not such a good idea to put all the code into one single file, right? And so the idea is to just split up this giant file, but then we need some functionality to export functionality from one file and to import this functionality into some other file. Okay? Easy as that. Export functionality from one file, import functionality into some other file. And you will see this pattern basically in almost every module system. Okay. One thing I am specifically mentioning I'm not talking about. I'm not talking about packages. So what is a package? What's a module? Well, a package consists normally out of several modules, out of several files, has a README file, a license file, a package.json file, and you publish it on NPM. Okay? This is not what I'm talking about. I'm specifically talking about modules. So, as I already said, JavaScript did not have a module system for a very, very long time. So what's the reason for this? Well, as you probably know, JavaScript was created in 10 days in May of 1995. And, well, 10 days is rather short for creating a programming language. So it's probably not too surprising that it did not have a module system back then. But now you might say, well, wouldn't it be cool to have a module system right from the start? Well, yeah, indeed it would be cool. But I think the reason why we did not have a module system is that JavaScript was meant to do small tasks. So, for example, replace one image by some other image on a web page, and not to build giant applications. Like the developers thought that, okay, let's use Java for that. That's, by the way, the reason why JavaScript and Java have similar names. That's just a marketing gag, okay? But, well, we did not stick too much to the plan. So we developed larger and larger applications with JavaScript. And, well, at some point, we need to factor out some of the code out of our applications and to put them into libraries. But then, of course, we need a way to use these libraries. And, well, how did we do this? Because, well, I mean, we had no module system. And basically, it looked more or less like this. So we had some HTML file, and inside this HTML file, we had a few script tags. We loaded, for example, jQuery, a few plugins, and then we used jQuery and these plugins. Okay, well, this apparently works, but how does it work? Okay, so every web page, even the web page I'm showing you the presentation on right now, has a global object. This is also sometimes called the window object. And every script which is loading on the page has access to this window object. So when jQuery loads, what it does is it pushes functionality to the window object. So jQuery decides, well, these few functions might be useful to the user, so let's push them to the window object. And now the jQuery plugins load and they say, well, we depend on jQuery. So let's go to the window object and grab jQuery. Okay, so that's not really an exporting and an importing how you have in normal module systems, because we have the window object in between, but you see the pattern. Okay, well, I said it works, but apparently it has a few problems. And the first problem you might have heard of is global namespace pollution. Okay, what do I mean with this? Well, because there are now several entities in a browser who put stuff on the window object. For example, the browser itself or if you are creating global variables or libraries, or there is even a weird thing, if you create an element which has a specific ID, then this element is put onto the window object. It's a little bit weird. So it's not too surprising that there will be name clashes. So at any point in time, you can never really be sure if the dollar variable on the window object still contains jQuery, or if it was overwritten by some other library, for example. Well, that's a problem. That's not so good. Next part is dependency management. So we said, okay, for our application, we do depend on a few plugins. So we had to include them as script text. Now these plugins said, well, we are depending on jQuery. So we, again, had to include the jQuery library. And now, well, let's think this further a little bit. Let's say jQuery would also depend on 3 other scripts. Then we also had to include them. And if these 3 other scripts also were depending on 2 other scripts, well, we also had to include them. And in the end, we are basically managing the dependencies of the libraries which we are using. And, well, that's not what we want to do. And the other part is loading order. So if we, for example, put the script tag for the plugin in front of the script tag for jQuery, then the plugin loads, the plugin goes to the window object and says, well, let's grab jQuery. Well, but jQuery is not there yet. And so we get funny errors like undefined is not a function. Next part is unnecessary things are loaded. So do you remember when I said that jQuery decides what it wants to push to the window object? Okay, that's a key point because jQuery does not know what you want to use, so it has to provide everything to you. And perhaps you are only using the event handling functionality of jQuery, but you're also getting the Ajax stuff, the DOM manipulation stuff, the CSS and animation stuff, and so on. So there's a lot of that code on the page. And, well, there's room for improvement there too. And the last problem I want to talk about, well, that's not a native ECMAScript only solution. So we need an HTML file in order to combine these scripts. Okay? We cannot do this only with JavaScript. Okay, well, but this creates a problem in environments where we do not have an HTML file. And, well, what is such an environment? Well, for example, Node.js. And now you might say, well, but Noches has a module system, right? Yeah, exactly. This module system was created exactly for this reason, because we cannot do what we are doing in the browser. So we have a module system. And the module system more or less looks like this. And again, you see the two parts, the exporting part and the importing part. And the exporting part, we are just assigning a function to this module.exports variable. And over here, we're requiring or importing the variable, and then we can use this function here. Okay? And now you might say, Alex, why are you always saying that's the Node.js module system? Isn't this the same as Common.js? And I think this is a common belief that this is the same as Node.js. At least I thought it for a very, very long time, and I encountered this many times when I was creating this talk. But, well, to be precise, this is not exactly true. Okay? So, to understand this, we have to dig a little bit into the history of Common.js. So, what's Common.js? So, in January of 2009, Kevin Denger created a mailing list, and this is the blog post where he announced this mailing list. And on this mailing list, he wanted to discuss a few topics related to JavaScript on the server side. Okay? So this mailing list, which was called Server.js and later renamed to Common.js, is not only about modules, but there were talks about a lot of other things. For example, promises. The promises which we have in browsers nowadays are based on the work which was done in Common.js. The packages being something you publish on NPM. Also, some of the design decisions for NPM were influenced by the packages in Common.js. There was work on workers, on the file system, on sockets, on the console API. And of course, well, there was work on the common.js modules. But unfortunately, Ryan Dahl, the creator of Node.js, had a few different requirements for the modules in Node.js. And so he created his own module system, which is based on the common.js module system, but it's not completely the same, okay? So, but they are so similar that I think 90% of the people, when they talk about the common.js module system, they mean the Node module system and the other way around. But, okay, the more you know. So, the Node module system is around and still very, very alive these days. But, well, what's the state of common.js, of this other module system? Well, it's not too great if you are a specification for server-side JavaScript, and the main implementation for server-side JavaScript, because Node became so popular, does not implement your specification. Or, to put it in the words of Ryan Dahl, forget common.js, it's dead, we are server-side JavaScript. So now you might think, well, so common.js, it's dead, yeah, it's dead, obviously, but so that was a failure, right? Well, not really. I pretty much agree with Isaac Schluter here, who said, but overall, I think the common.js project can be considered a success because it started the conversation about modules. And it brought us a lot of things like promises, which I talked about earlier. And it also gave us one other thing, and this is AMD, the so-called asynchronous module definition. So you might have heard that basically common.js is the module system on the server, and AMD is like the counterpart to this. That's the module system for the browser. But I mean, again, that's not entirely true because, again, AMD was based on a common.js proposal. And now you might ask, okay, well, what's AMD actually? I've never heard of this. Well, perhaps you have heard of Requirejs. And Requirejs is the most prominent implementation of this asynchronous module definition. And again, we have the two parts. We have the exporting part, or the part where we define a module. And we have the importing part, where we say, okay, well, I want to import this module, and when this module is loaded, this function is called. You can think of it like a callback, and the parts which are loaded are passed into the function here, and then we can use this. Okay. So, well, common.js is dead. So what about Requirejs and AMD? Well, they are still alive. In fact, they saw a release around a month ago. But in this release, James Burke, the creator and maintainer of common.js, already said he is hoping that they, meaning AMD and Requirejs, are not around for another 6.5 years. So it's already that long since they were created. Please hasten their retirement by finishing a native module system. So there's also the plan from Requirejs that we at some point deprecate this and move over to the native module system. But that's obviously a problem because we cannot, like, from one day to the other, switch out the entire module system. So we will talk also about this transition later a bit. So now, in the following years, after the creation of Requirejs and Node.js, the Node.js module system established itself on the server for server-side modules. On the other hand, on the browser, AMD established itself. And now if you were a library author, you were like, so I want to write a module which is working on the server side, and I want to write the same module which is working inside of the browser. So what do I do? And there came a few solutions to this problem. And one of these solutions is Browserify, or the idea that we write our modules in one module system and then in some way transform from in this case, from the Node module system to something which the browser can use. Okay? This is what we still use today in the form of Webpack, Rollup, or other tools, Babel, for example. But the idea, the module system transformation is still very alive in today's tools. The other solution which came to this problem, so Node.js module system versus AMD, is the so-called universal module definition. So in the previous solution, we always had this, we need to transform the module system, but now the idea is like perhaps we can write our module in a way that it can be consumed by the browser and it can be consumed by the Node.js module system. And well, so UMD got created, and basically UMD is a collection of a few snippets which more or less look like this, okay? And you already see, that's not too clear where we are actually doing the exports or where we are doing the imports. And well, if you look at this longer, you see, okay, well, down here, we would write our library. So that's a lot of boilerplate to do. And if you're writing 3-line modules, like having a boilerplate of 20 lines, it's perhaps not such a good idea. And I think this is the reason why UMD never really took off, or why it's not really around any longer. Because, well, it's died more or less of a little bit too much boilerplate. But I'm not saying that's a bad idea at all. So I hope I have convinced you that we kinda need an ECMAScript module system. And well, fortunately, we have an ECMAScript module system, at least since approximately a year, when the ECMAScript 2015 standard got created. So this is also called ES6, if you're more familiar with that term. So, and in this ECMAScript 2015 standard, we have the declaration of the syntax of the ECMAScript module system. And this more or less looks like this. Again, we have the division into two parts. First, the export part, and then the importing part, which will come on the next slide. And first of all, there are two different ways of exporting modules in the new module system. The first one is the default exports. That's the one you will probably use the most. And there are a few key facts about this. Every file can only contain one default export, and you are probably using this default export when you're only exporting one thing from a file, or if there is one very important function you want to export from this file. And then there are the named exports. You would probably use them for like the less widely used functions, perhaps. And you identify the named exports by some key. So in this case, it's some class, some function, or some object. And we can later use these names to import these again. Okay? So we will see this on the next slide. First of all, for the named imports, so we say, okay, we want to import from this file, so we are going to the file some file, so there can also be a package descriptor or some path or so, and then these curly braces say, okay, we are looking for a named export, or we want to do a named import, so we're looking for a named export, and this named export should have the name some function. So we are going through here, and we see, okay, well, there's the export some function. We put this into this variable, and we can use this down here. For the default imports, it's similar, but just note there are no curly braces around here. It's the same, go to the file some file. And since there's only one default export in the file, we are just saying, okay, well, we put the default export into this variable func, and we can use this later. Okay. That's pretty much everything I want to tell you about the syntax. There is more to the syntax. So for example, you can rename named imports immediately when you are importing them. You can import several things at once and combine default imports and default imports. But if you keep that syntax here in mind, that's getting you very, very far. Apart from the syntax, there are a few more things when working with the new ECMAScript module system you should know. And one of the things is imports and exports must be at the top level. So they cannot be contained inside of an if block, or inside of a for loop, or inside of a function. Okay? But they have to be at the top level. So this will not work, and not only for the imports, but also for the exports. And well, why is this? Well, if we look at this example, and we only can see what file we are importing, this one or that one, during evaluation of the file. Okay? If we put this at the top level, we can already see this during compilation of the file. So we can load the other files earlier, is one of the advantages. And the other big advantage, which you should definitely not underestimate, is this makes static analysis possible. Okay, what do I mean with this? So we can have tools like, for example, linting tools like ESLint, or module bundlers like Webpack or Rollup. We can have them analyze this file, and they clearly know what other modules is my current module importing. And because of this, we can create smaller modules, but more on this later. So it's a great tool for debugging and for linting and all this stuff. Next part, imports are hoisted. So this is working. You can use a function before you have imported it, because basically you're going once through the file, looking for all the imports, load those imports, and then you're executing the file. But I think this looks a little bit weird, so I would say if we put the imports at the top of the file, that's probably best for readability. And the next part is that imports are read-only views on exports. Okay, well, that sounds a little bit complicated. What do I mean? So let's say we have two files, the left file and the right file. So in the left file, we declare a variable named counter, and we set the value initially to 3. And we have a function which just increments the counter variable here. Now, on the right side, we are importing this counter variable and this increment function from the left. And first, we try to increment the counter ourselves. And this will give us a type error because we cannot change in any way the imports. That's what I mean with read-only. And then the next part, okay, if we lock the counter, that's obviously 3. If we increment the function, this is calling this function over here, so the counter variable will get incremented to 4, and also down here this counter variable is equal to 4, because up here at the import we are not copying the values over to our new file, but we have a live view onto these other values. Now you might say, well, that's probably a little bit weird if something changes in the other file, and I don't really want to have like the changes from the other file in my file or so. Well, I have used the module system now for around a year, something like that, and I have never ever run into this problem that some other file changed my value in some way. And well, if you want to have a copy, you can just say my counter is equal to counter, and you're fine. So now we can go back and say, well, we had these old problems earlier. So the global namespace pollution, well, is this problem solved? Well, I would say yes, because we do not rely on the global namespace any longer. We do not have to put something onto the window object in order to reuse it later. We just declare what we want to import, and we have it. Okay? I would say that's solved. The next part is dependency management. Again, I would say that's solved. We are saying, I want to import jQuery from jQuery, and I get jQuery. I do not have to specify in what way my libraries are loaded, and I do not have to manage the dependencies of some other library. This is all solved for me. Now comes the interesting part. The unnecessary things are loaded. Do you remember when I said earlier that we can do static analysis on our module system just because we put all our import statements at the top level? Okay? So this means tools like Rollup, Webpack, Bible, and so can determine at compilation time, or when they are running, what other modules we are loading, and especially what functions from other modules we are loading. And so they can create bundles which only contain the functions which will eventually run on your site. So there is no dead code on your web page or in your module any longer. So I think we ultimately solved this problem. And next part, well, it's not a native ECMAScript only solution. Well, that's also solved. We can import modules using ECMAScript or JavaScript. That said, well, of course, the browser also has to do something, and there are things we can do in HTML and so on, but we will cover this a little bit later. But we can work only in JavaScript. So I think that is solved too. But now you might say, okay, well, so we have solved a few problems, but if we are creating a new thing, perhaps we also created a few new problems. So I think most of those problems will only show up when we use the ECMAScript modules more extensively. But one of the biggest problems I see is basically the following. So that's from XKCD, how standards proliferate. Situations, there are 14 competing standards. 14, ridiculous. We need to develop one universal standard that covers everyone's use cases. Yay! Situation, there are 15 competing standards. So I'm pretty sure that there will, at no point in the future, all the modules be written only in the ECMAScript 6 module system. That's not just going to happen. But at least we can try to move over a few parts to the new ECMAScript module system. On the way there, I think we will encounter a lot of problems in a way that, like, the module systems are not really working well together and so on, and there is still a lot of talk on this topic. So now you might say, well, so I want to start implementing ECMAScript modules tomorrow, but I cannot use them because why are modules not yet implemented inside of the browser? Well, this problem basically boils down to the difference of syntax versus semantics. Okay? So if we have this statement here, the syntax is, okay, we have the import keyword, a space, an identifier, a space, a from keyword, a space, a string literal, an optional semicolon. But the semantics, that's something entirely different. So, for example, when Node.js sees this line, Node.js says, okay, well, Lodash, for this I have to go to the node_modules folder to look for a Lodash folder, and inside of this Lodash folder, there's a package.json file, and I go to the main key, and now I get the file which I have to load. Well, that's working fine for Node.js. But inside of other server-side environments or inside of the browser, well, this loading has to be a little bit different. And for this reason, this semantics part was pushed out of the specification. Okay? So while the syntax like exists for around a year, the semantics only landed in January of this year into the what we get HTML specification. And now all the major browsers are implementing these modules. But you do not have to wait for these browsers to finish their implementation, because there are already tools out there like Babel you can use today to transform your module system into a module system which can be used today. And you have a lot of advantages like the static analysis which I talked about earlier. And now, if this sounds interesting to you, here are two resources, exploringjs.com, an excellent book by our Axel Rauschmeier, and the other part, jsmodules.io. I basically put it in there because that's a short, nice summary, and that's a URL you can remember probably. And so read a little bit on it and start using the S6 module system. So now we talked about the past. The module systems we had some years ago, and they are still around today. We talked about the present, the ECMAScript module system. And now I want to talk a little bit about the future, and especially about three things which are currently being discussed. So one of these things are built-in modules. So what do I mean with built-in modules? So let's say the ECMAScript specification wants to provide some new functionality to us. For example, SIMD. You can also think like the math object. The ECMAScript specification is providing us the math object, and it's doing so by pushing this functionality to the global object. Okay? And that's exactly the pattern which we saw on one of the first slides. And we said, well, that's perhaps not the perfect idea. So wouldn't it be cool, now that we have such a cool module system, that we are also using this module system in order to, for example, import the SIMD object or the math object or some other global object? Would make sense, right? But then we have a problem, and the syntax is not really clear. So here are three examples how this might work out, but as I said, that's not really clear nowadays, because the problem is we do not want that this identifier is clashing in any way with an existing module on NPM, and this should also not be a path, because we can also load modules via a path. And so we do not want to override some other modules, and so that's still up for discussion. So now you might say, well, let's introduce a completely new syntax. Well, that's also not working, because we want to still be able to polyfill them. So meaning we want to provide the function to the browser or to Node.js before the browser or Node.js have implemented them. So in some way, we want to disallow the user from creating a module with this name, and on the other hand, we want to allow this. So that's like a weird problem. The next part is system.import, or the module loader specification. The module loader specification provides a different way of loading modules. And it's working in a way that we say, okay, system.import, this function here. This function here gets an identifier for some module, and then it returns a promise. And when this file here is loaded, this promise is resolved, meaning this function here is called. And we push the module, which we just loaded, inside of the function, and then we can use some of the exports inside of this function. This gives us a very, very big advantage. And this advantage is that we can load modules at any time we want. With the import statements, we can only load the modules once the page is loading, because then all the modules are loading, which we have specified using this import syntax. But there might be a few cases. For example, you're loading a blog post. And when you're loading a blog post, you want to get the content on the screen very, very fast. So you try to load as few things as possible. But once the user has scrolled down a significant bit, it might be possible that your user wants to use the commenting functionality. So then, after some time, we are loading the commenting functionality, and we can use it with this syntax here. But on the other hand, you might ask, why aren't we using this syntax all the time? Well, because on this syntax, we cannot do static analysis any longer. So we cannot build these really small bundles. So again, there are two use cases, and use the tool for the use case you want to have. And the last point I want to talk about is the point of scripts versus modules. So the ECMAScript 2015 specification introduced a new way of executing JavaScript code, and that's the module way. So the script way, that's the way of executing JavaScript code which we always had. But then there's a new way. And we as developers should not fear this too much. I mean, this looks like a lot, but it's not too much. It's by standard in strict mode. We are not doing weird stuff with the global object. We are executing code asynchronously instead of synchronously. Well, we can use this import statements, which I talked about earlier. This part here is this system.import API, which we had on the previous slide. Okay, so for us as developers, it's not changing too much. But, well, for a browser, now the browser has two different ways of executing JavaScript code. And the browser is now like, well, should I execute this as a script, or should I execute this as a module? I don't know. So the first idea obviously is, well, isn't a module always when there's an import or an export statement? Well, not really, because there can be modules which do not have an import statement or an export statement. So we cannot use this to identify modules from scripts. So we need some other idea. One of the ideas was to have the file extension specify whether we have a module or we have a script, so introduce a new file extension. But in the end, we settled on the script type with an additional attribute called module. So you can use this like as a normal script tag. You just put the type module on it. And that's working fine in the browser, and the browser knows that it has to execute things as a module. And if you look closely, this is already in the standard. So there, it was specified. So now I said, well, it's already specified. So why am I telling you this in the section of future parts? Well, I said it's specified in the browser. Node.js is an entire different thing. Okay? And so browser behavior is specified. What about Node.js? Well, for Node.js, the idea is to use the old module system as a script and the new module system as modules. And now the discussion is again, so okay, how do we identify how we load things and so on? And there are basically two ideas nowadays, that we have a new file extensions for ECMAScript modules. So we might see something like .jsm in the future, which should more or less for us in the same way as the .js extension, but it just indicates to Node.js that it's doing something else. Or there might be that we have to some way specify how we want to execute stuff in the package.json file. But please do not be too afraid of like, oh yeah, there is a new way of executing code. That's not really a problem, I think. It is improving a lot of things. Or, well, to put it in the words of Dave Herman, it's a better semantics, better global environment, better language. And, well, isn't a better language something which we always wished for in JavaScript? Thank you.